So the first concept for us, this is going to be a high level discussion, but still will be sufficiently in detail that physician friends or healthcare workers, friends, providers, clinicians can actually take a lot of concepts from here as well. The idea of autophagy is this. Imagine this is a cell, and this cell has encountered some pathogens, let's say a virus, SARS-CoV-2, or a bacteria or some other offending agent on the outside, or this cell has gotten something already in it. For example, the virus has entered the cell and now it is making more viruses. And so let's say there is some debris within the cell. What cells do is they capture these debris within their own system, within their own space, in little tiny pockets, which we say vesicles. And when a cell captures debris or waste material in a pocket, we call it a phagosome. Phagosome stands for eating. This is how a cell eats. Now, the problem for this cell is that once it has captured a bunch of debris or viruses or bacteria or fungus or other offending agents, now it needs to digest this. It needs to break down these elements into smaller pieces, which then it would consume as normal raw material for other things. How this cell does this is such a unique thing. How it does this is inside the cell, there are thousands of tiny little vesicles or pockets, or imagine stomachs, which have acids in them. So what the cell does is it picks up this waste material or a garbage can it has filled, and then it combines that with, imagine this is a garbage thrasher. So it fuses these two, and that makes a phagolysosome. Lysosome is this pocket which has lytic enzymes. Lytic enzymes are the enzymes that are going to break down the waste material. Once these two are fused, then the offending agent or debris or waste or trash is broken down into smaller pieces. So here is a very delicate and important point to keep in mind. Once the debris is broken down, the cell has accomplished a process of removing the offending agent. And the second thing is that cell is going to now present that offending agent or pieces of it on its surface, so that the immune system cells, for example, natural killer cells or dendritic cells or macrophages, T cells, B cells, they can come in contact with this offending agent's piece, and the immune system could become activated to help the body, the tissue, to become healthy again, to remove these problems. This is a normal process. Now, here is another delicate point to keep in mind. If for some reason this cell fails to perform this fusion and to break down this material, by the way, this process is called autophagy if the material is picked up from within the cell and destroyed. If it is from outside, it is not exactly autophagy, but if it is from within, then it is called autophagy. The cell is cleaning out its own house. If for some reason the cell is able to collect the waste material from inside, but not able to digest that, then this cell is going to develop inflammasomes. It's going to become angry. It's going to say, there is something here which I cannot take care of. So I am going to start the inflammatory processes, and I'm going to activate the immune system, and I'm going to have them destroy me and my neighboring cells to clear out this whole field. That is inflammasomes behavior. That is a fiery death that a cell would get. And we've done a complete lecture about that separately in Long Story Short series. Now, what we would like is that a cell does not do inflammasome-based behavior. Instead, it can do the autophagy, clear out the waste material, become happy and healthy, and continue on living in a more normal way. Now, things like SARS-CoV-2, and especially the proteins like spike protein, these have this special problem, especially the spike protein. And this always gives me this pause that how could this virus just come up with this spike protein on its own, which has such functional diversity and such damaging functions that we have never seen them before. Anyways, the spike protein and other proteins of this virus can actually block these two vesicles from fusing with each other. Imagine then what would happen. A cell gets infected, gets a spike protein in it. It has captured the spike protein in a vesicle. It is now trying to connect that spike protein vesicle with a lysosome to kill it. to destroy it, to trash it, to thrash it. And it cannot do it because spike protein and the other virus material has inhibited the cell from doing it. This cell would become upset and start activating the inflammasomes and start causing inflammation. So a cell with the spike protein in it is actually unable to do autophagy because the virus and the spike protein's presence has prohibited the cell from doing the autophagy. So how can we now have this cell perform autophagy? So there are multiple ways. We can look at the cell and say, all right, we should just kill this cell. And that is how the spike protein can be cleared. The problem is when the cell will be killed, then the spike protein and the cell will be eaten up by another cell. And now the spike protein has simply transferred over to another cell. And now that other cell has the same problem. The other mechanism will be to request this cell to perform autophagy so that the spike protein can be destroyed and thrashed and trashed. And then pieces of that can be shown on the surface as well. And immune system can become activated, correctly activated instead of overactivated while we are clearing the trash out. So what do? We can do intermittent fasting. We can use resveratrol, or we can use spermidine. And there are a number of other therapeutics as well that can help with autophagy. These are the topics for today. Now, for the intermittent fasting, we have done a discussion previously. I would request you to watch that video. It is in the long story short. I'm going to speak more about resveratrol and spermidine. There are other therapeutics as well. We can talk about them in the future. So get ready for this one. Here is how this whole mechanism works. Imagine you are inside the cell. You have taken a little tiny helicopter, you sat in it and you went in the cell and you are inside the cell. Inside the cell, what you would see is that cell has a little protein called ribosome. Ribosome's function, this little one over here, is to produce new proteins. We will call it protein translation. Then in this process of making proteins, there is a very important protein that is formed. Of course, all proteins are formed in this process, but an important protein that is formed is called putrescine. Putrescine protein is formed as part of the protein translation. This protein, putrescine, is then further modified by an enzyme which is called spermidine synthase. So synthase are the enzymes that make things, they synthesize things. So spermidine synthase picks up putrescine and converts that into another protein called spermidine. And I made it look like a little sperm. So it is called a spermidine, but it's not a sperm. Spermidine's function is to induce autophagy. It takes the vesicle with the virus in it or the spike protein in it. This is the phagosome. And it brings the lysosome next to it and it induces their fusion. So when the fusion would occur, the digestive enzymes from the lysosome will spill into the phagosome, and that would cause the breakdown of the spike protein and the other debris. So you would agree that spermidine is a very important part of autophagy. There is another little protein called beclin. Beclin's function is to initiate the autophagy. What does that mean? It would help produce the proteins, the enzymes that would start bringing these two guys together, phagosome and lysosome, and fuse them. So beclin and spermidine are important parts of normal function for autophagy. Now, check this out. Once the spermidine is formed, spermidine does one more thing, and that is there is another protein in our cells that is called eukaryotic translation initiation factor. What does it mean? Really, this protein's function is to work with mitochondria to keep mitochondrial function healthy. So spermidine now has two functions: help with inducing the autophagy, which is very healthy mechanism for a cell, plus help keep its mitochondria healthy as well. Spermidine is the only protein that can do hypocyanation of this protein. It's a chemical function. This is the only one unique function in our body that can happen through spermidine. No one else can do this. And this is necessary for the correct energy production. Now, here is the interesting thing. Check this out. SARS-CoV-2 will disrupt spermidine production. How will it disrupt that? By two mechanisms. Mechanism one, it disrupts our ribosomes. How does it disrupt ribosomes? One, it actually takes them over to make more SARS-CoV-2. Secondly, I actually did this study about a year ago. SARS-CoV-2 can actually cause the ribosomal construction to be abnormal as well. So ribosomes are not really correctly functioning. These little proteins become disoriented. So one, the new proteins that are necessary for the cell are not being produced correctly. And second, the SARS-CoV-2 works with the spermidine synthase. Remember over here, this spermidine synthase? SARS-CoV-2 disrupts this enzyme as well. So then what do we have? We have two problems. One problem is we are not making enough proteins. And secondly, whatever tiny amount of proteins we're making, from those proteins, making spermidine is even more difficult because the spermidine synthase enzyme is not working. This is SARS-CoV-2 doing it. This is spike protein is taking part in these things. So it is not just that the spike protein is sitting in the cell and just being a problem for the cell, that it is not being digested. The whole virus and the spike proteins are causing more damage by dysregulating a lot of other mechanisms of the cell. So here, when the spermidine levels are low, then of course you can see that the spermidine's function was to induce autophagy. That autophagy induction is reduced. Now what would happen? When the autophagy is reduced, there is debris in the cell, there are spike proteins in the cell, these are being picked up to be shredded, but we are not able to do that. And the cell would become upset, it would create inflammasomes, and the inflammasomes would cause inflammatory outcomes. And that can become a cytokine storm and even kill a patient. So it is paramount that the spike proteins are cleared out. And you are seeing actually the result of spike proteins hanging out in a person in the form of long COVID, in the form of vaccine injury. So what do we need to do? First of all, we need to have appropriate amounts of spermidine. So if we cannot have spermidine in a cell in the right amount because the spike protein is there, or the virus is there, or the cell is injured for other reasons, inflammatory molecules, and it is not able to produce it, then what do? You provide it from outside. So the studies that Dr. Merrick shared with me and we studied, they say that spermidine from outside, when that is given, not only SARS-CoV-2 replication reduces by 80-85%, but the inflammasome production reduces as well. So the disease doesn't become very severe. Can you imagine that? And they said that it is prophylactically helpful as well. That is, you could give it before, you could treat the cells. They did that in vitro. They treated the cell with spermidine, then infected the cell. And the presence of spermidine inside the cell disrupted the virus's behavior. And the autophagy continued and the cell was able to stay healthy. Then there is another protein called beclin. Beclin is the initiator of autophagy. Now, keep this in mind as well. If you are not able to do intermittent fasting in a structure where autophagy could be initiated correctly, for example, let's say you're snacking or the durations of the fastings are not correct, then at least there are external chemical or supplemental substances that can help trigger autophagy. This is the miracle of these substances we're talking about, resveratrol and spermidine. So there is another protein called beclin, which is also in the cell. Beclin's function is to initiate autophagy. And it does that by working with these two proteins it uses. SARS-CoV-2 also destroys beclin. The spike protein and the other virus proteins, they cause a upregulation of two other proteins in our cell, which in turn go and destroy beclin. And when beclin is destroyed, then the autophagy is reduced again. So imagine if you can give spermidine, initiate the autophagy, which would clear out the spike proteins and clear out other debris. That would also help beclin to be present in the right amounts, and that would help the cell regain health faster. This all looks like miracle to me. This is such a beautiful mechanism. And nowadays, there is a lot of focus on intermittent fasting and autophagy. Okay, continuing. Imagine for some reason, beclin is not present correctly, that is SARS-CoV-2, for example, a spike protein, or for some reason, spermidine is not present in the correct amount. Then what happens is autophagy is not done correctly. And when that is not done, the cell would start filling up with the trash. For example, let's say spike protein. and cell cannot do anything about it. It cannot remove it. It has captured it. It wants it to be removed, but the autophagy is downregulated. So what happens is cell's alternate mechanism is to initiate inflammasomes. Inflammasomes are small vesicles within a cell. This cell is saying, I'm going to die now, but while I'm dying, I'm going to create so many signals for inflammation that I'm going to kick up a storm of an inflammation. And that storm becomes cytokine storm. So inflammasomes are activated. That is a frustrated behavior of the cell to say, I can't get rid of this. I'm just going to become angry. You would agree that we do not want inflammasomes. So then what do we do? Spermidine is one answer. The other answer, of course, intermittent fasting is another answer. And other answer is resveratrol. Resveratrol is separately available, plus it is part of red wine as well. Now, resveratrol, it does something very interesting. Here is that mechanism. And this is the last part of the discussion. Inside a nucleus. So now within the cell, we have gone in the nucleus. Inside the nucleus, our DNA is wrapped around tiny little balls or proteins. These tiny little proteins are called histones. Why do we keep the DNA wrapped around them? For two reasons. Number one, the DNA is a very long string. And if we just leave it without properly organizing it, then we cannot, this string would become jumbled up and tangled up. So we neatly wrap it around histones so that it does not become tangled. Secondly, histone wrapping allows a large amount of DNA to be packaged in a small nucleus. There is now a duty, and that is whenever you want to use DNA to create proteins, you have to unwrap or open up the genes around histones, use them to make mRNA or messenger RNA or copy those DNA parts, and then rewind them on histones. It's a beautiful mechanism going on inside our cells. So how does that happen? There are so many machines, there are so many enzymes whose function is to loosen up the DNA around a histone, use it to make a copy of it, and then tightly wrap it again. The SIRT1 is a protein enzyme. It is an enzyme family of sirtuins. This enzyme, it functions to tightly wrap DNA on histones. You can think of this as the function of SIRT1 is to help with the gene expression of a cell that is in need of various functions. Resveratrol activates the SIRT1. So resveratrol helps with the DNA expression inside the nucleus, which in turn would then help with autophagy, and I'll show you how it does that. But once the autophagy is helped with resveratrol, then inflammasomes will not be produced. So now let's see how does it do or what does it do. When SIRT1 or sirtuin-1 is increased in amount by resveratrol, then what happens is it in turn reduces the function of another protein called ADAM17. That protein, when that is reduced in amount, it reduces tumor necrosis factor alpha and interleukin 6. Have you heard of interleukin 6 blockers throughout the COVID time? There have been drugs to be used for interleukin 6 block. Here, resveratrol would increase SIRT1, which would reduce ADAM17, which would reduce interleukin 6 production, which would reduce inflammation. That is one of the functions. Another function is SIRT1 improves the autophagy by modifying the gene expressions in favor of those genes that would help produce enzymes that trigger autophagy. But not only just that, resveratrol would reduce apoptosis. Apoptosis is the death of the cell. We do not want cells to just start dying. So let's say there are cells that have spike proteins. We don't want those cells to just start dying. We want them to do autophagy and become healthy instead of just dying. Resveratrol would cause SIRT1 to increase inside the cell, which would reduce the cell's capability to die. It would ask the cell not to die. What a beautiful help. And then a hugely important thing, when SIRT1 protein is increased, it reduces hypoxia. Hypoxia is another damaging aspect of SARS-CoV-2 and the spike protein This shortness of breath is an example of that hypoxia, correct? Or is a symptom of that hypoxia. And just by improving autophagy, by the resveratrol, we are getting better autophagy, less inflammation, less apoptosis, less hypoxia. And of course, just to repeat it, the second drug is spermidine. So this is how these two drugs work. And of course, if you didn't want to take these drugs or these substances, then the other one is intermittent fasting. My thinking is, and that is what I do as well, I do intermittent fasting regularly now.